Hi, Algebra 2 students. Welcome back. I hope that 7.4 went well for you, that you're catching on to this concept of logarithms and the graphs of logarithms. And I hope that you have been able to pop into the math tutorial lab in F107 to get your questions answered if you've been struggling. So what we're going to do is we're going to go ahead and move forward, and we're going to look at applying properties of logarithms. And this is going to give us some tools for our future sections in which we will be able to solve logarithmic equations. So we have several different properties here. Our first property is called the product property. Okay, so if you have a product in your logarithm, okay, log base b of m times n, then that means that we can do what we call expanding it into two logs that have the same base. And actually, this is supposed to be log base b of n right there. So it's log base b of m plus log base b of n, all right? The quotient property means if we are dividing m by n, okay, then we can expand that log into two separate logs that have the same base. So log base b of m minus log base b of n. So multiplying, we expand it into the addition of two logs, and dividing, we expand it into the difference or subtracting the two logs. And then lastly, we call this last property the power property. So if we have a power in our log, we're just simply going to take that power and we're going to bring it down in front. Okay? So what that gives us is n times the log base b of m. So we're going to practice expanding these a bit. And then we're going to talk about changing the base. Actually, you know what? Let's go ahead and talk about that because I think we might need it in this first example. So before section 7.5, we had to kind of evaluate these logarithms mentally unless it was common log base 10 or natural log base e. So now what we can do is we can take a logarithm with any base and we can change it to either common log base 10 or natural log base e. Okay? So if I have log base c of a, what that's equal to is the log of a divided by the log of c. And that's if we used common log base 10. Or if I have log base c of a and I wanted to change it to base e, I would use the natural log of a divided by the natural log of c, and then that's something that we could evaluate in our calculator. Okay, so let's look at example number 1. What we're going to do is we're going to use this first property, the product property. Okay, so I have a product of 4 times x. So what I'm going to do is expand the log, and I'm going to expand it into log base 2 of 4 plus log base 2 of x. Okay? Now, any log that you can simplify, you're going to want to do that. Simplifying meaning to like a rational number, you know, either a fraction or an integer. If it's a decimal number, you probably just want to keep it as a log. But we know that 2 to the second power gives us 4, so that means that log base 2 of 4 is equal to just 2. Okay, so we're going to simplify that and write it as 2 plus log base 2 of x. So that's expanding the log. All right. Now on example 2 here, what we're going to do is we're going to use a combination of both this product property and the quotient property. Okay, the first thing you want to do is split up the quotient. So we're going to split it up in, say, log base 3 of 5x minus log base 3 of y. Okay? Now, I want to expand the log base 3 of 5x because we have a product. So we're going to do that portion like we did example number 1. So we're going to expand that into log base 3 of 5 plus log base 3 of x. And then we're going to subtract log base 3 of y. Okay? So that right there would be our final expansion of that log. Okay? Let's look at number 3 here. What we're going to do is we're going to expand the natural log of 3x squared divided by 5y cubed. So we're going to use all 3 properties here. So the first thing we want to do is the quotient part. So I'm going to split it up into the natural log of 3x squared minus the natural log of 5y cubed. So that is my quotient property. Next, what we want to do, okay, is we want to split up the product. So I have 2 products here. I have this product and this product. Now, since I'm subtracting, I'm going to go ahead and put this in parentheses because when we go to split this up, we're actually going to need to distribute some negative signs. So let's go ahead and split this guy up, natural log of 3x squared, into the sum of the natural log of 3 plus the natural log of x squared. Okay? Minus the natural log of 5 plus the natural log of y cubed. Okay? So then that means we need to distribute this negative sign. So the natural log of 3 plus the natural log of x squared minus the natural log of 5 minus the natural log of y cubed. The last step is to bring these exponents down in front. Okay, that's the power property. So we're going to have the natural log of 3 plus 2 times the natural log of x minus the natural log of 5 minus 3 times the natural log of y. And that's going to be our final answer right there. That's fully expanded. What I want you to make note of is that anything in the denominator should be represented by a negative log. Okay? And anything in the numerator should be represented by a positive log. And we're going to get into that in our on the back side of this when we condense some logs together. All right, let's look at example 4 here. This will be our last expanding problem. What we're going to do is we're going to first rewrite the radical using exponents, using our rational exponents. So let's rewrite it as log base 4 of the quantity 3xyz raised to the 1/2 power because it's a square root. Okay? So then what we want to do next is we want to bring that exponent down in front. So we're going to rewrite it as 1/2 of the log base 4 of 3xyz. Okay? Now that whole quantity 3xyz is all under that radical. Okay? So it's important that we put some parentheses around that log. Now what we're going to do is use our product property, and we're going to split up the product of 3 times x times y times z. So what we're going to do is we're going to have a 1/2 in front, and we're going to split it up into log base 4 of 3 plus log base 4 of x plus log base 4 of y plus log base 4 of z. Okay? And then, if you want to, that would be a a fine answer right there if you wanted to stop right there. Otherwise, what you could do is you can distribute that 1/2 into each log. You can distribute that 1/2. Okay, so what that will look like for us is 1/2 log base 4 of 3 plus 1/2 log base 4 of x plus 1/2 log base 4 of y plus 1/2 log base 4 of z. Okay, and that's going to be the final answer right there. Okay, so it's really important that you have a 1/2 in front of all of these logs because all of those letters were all underneath the radical as well as the 3. Okay? All right, so let's move on to the back side here, and what we're going to do is we're going to talk about condensing logs. So we're going to do the opposite of expanding. We're going to put them together. Okay? So, like I said, anything that has a positive log, those go in the numerator, and anything that's a negative log will go in the denominator. Okay? So let's first start off by let's go ahead and condense using the reversal of our product property. So we're going to turn, actually, you know what? Before that, what we want to do actually is do our power property. So what we want to do is we want to move this 3 up into the exponent position. So let's rewrite it as the natural log of 4 plus the natural log of x to the 3rd power. Okay, and then we'll go ahead and subtract our natural log of 12. So now let's condense these two guys here. And we're going to multiply them together since it's the sum of 2 logs. So we're going to rewrite it as the natural log of 4x cubed minus the natural log of 12. Okay, and now since we have the difference of 2 logs, now we're going to divide the quantities. So the natural log of 4x cubed divided by 12. Okay? And the last step you want to do here is just simplify, okay? So 4 divided by 12 is a fraction that we can reduce to 1 over 3. So then we want to just reduce that and say x cubed over 3. And that would be our final answer if we condensed that log, okay? So let's look at example 6. So the first thing you want to do is your power property. So we want to bring these powers back up into the exponent. So let's rewrite as log base 5 of 4 plus log base 5 of y to the 1/2 power minus log base 5 of 3 squared. And let's just do a little bit of simplifying here. Let's see, log base 5 of 4, I'm good there. But let's go ahead and write log base 5 of y to the 1/2. Let's write that as the square root of y. And then also let's turn log base 5 of 3 squared into log base 5 of 9. Okay, so now let's go ahead and let's condense using our product property. Okay, so we're going to rewrite as log base 5 of 4 root y minus log base 5 of 9. And lastly, we're going to use our quotient property and divide. So what we have is we have log base 5 of 4 root y divided by 9. And that is going to be the final answer right there. Okay? And let's see, example 7 here, our last condensing problem. Let's see here. The first thing we want to do is let's go ahead and do the parentheses. values. Let's go ahead and rewrite by condensing those into 1 log. Okay, so let's write it as 2 times. Since we're subtracting, we're taking a difference, that means we divide. So log base 3 of 20 divided by 4 plus 0.5 times the log base 3 of 4. Okay, so let's go ahead and simplify. We'll call the 20 over 4, we'll call that a 5. Okay, so it's 2 log base 3 of 5 plus, you know what, let's turn this 0.5 into a 1/2. Okay, all right. So now what we want to do is we want to move our exponents back up into the exponent position. Okay, so rewriting that, we're going to have log base 3 of 5 squared plus log base 3 of 4 to the 1/2 power. Okay, now let's simplify here. So let's see, log base 3 of 5 squared is 25, right? And 4 to the 1/2 power is the square root of 4, which is equal to 2. So let's change that to log base 3 of 2. Okay? And then lastly, since we're finding a sum of 2 logs, we're going to use our product property and we're going to condense them into the log base 3 of 25 times 2. So that's going to give our final answer of log base 3 of 50. Okay? So now we're going to practice that very first concept we talked about back here in the front page. We're going to talk about evaluating logs on your calculator with any base. Okay? So we're going to use that change of base formula to evaluate these logs on our calculator. So if I was going to use common log base 10, what I would do is I would rewrite as log of 8 divided by the log of 5. Okay? And I would grab my calculator and I would find that button that says log on it, find that log button, and I would carefully type that in, and what that gives us is approximately 1.29 if we round it to 2 decimals. Okay? Or you can use the natural log button. That's okay. If you want to use the natural log base e, we could say natural log of 8 divided by the natural log of 5, and that also gives us 1.29. Okay, so it doesn't matter which way you do the problem, but you're changing it either to common log base 10 or natural log base e so that you can plug that into your calculator and evaluate that. Okay, so let's look at part B here. We're looking at log base 26 of 9. How would we evaluate this on our calculator? Well, we could change it to common log base 10. So I could rewrite the problem as log base 9 divided by log of 9 divided by log of 26, which is base 10. And then I could evaluate that on my calculator, which gives me approximately 0.67. Or you can use natural log, and you can say the natural log of 9 divided by the natural log of 26. And that will also give you 0.67. Okay, so it doesn't matter which way you do it. Okay, and lastly here, let's do log base 12 of 30. If we were going to change it to common log base 10, we would rewrite it and say log of 30 divided by the log of 12. And that's going to give us approximately 1.37. Or we could use natural log. So we could say the natural log of 30 divided by the natural log of 12, and that should give us the same answer using log base 10, which is 1.37. Okay, So what I want you to do is I want you to practice plugging some of these in to your calculator so that you are comfortable using those change of base formulas, because in the next section, when we start solving logarithmic equations, you are going to need to be able to change that base so that you can evaluate it. Why don't you take a second to evaluate example number 7, log base 3 of 50, and changing that base and plugging it into your calculator to see if you can get the right answer. So what I want you to do is go ahead and pause the video, and I want you to see if you can find the log base 3 of 50. And when you're ready to check your answer, go ahead and resume playing, and we'll look at the answer. Okay? So if you pause the video and you're now resuming to see the answer, what I would do to evaluate log base 3 of 50 is I would change it to log of 50 divided by the log of 3, or I could change it to the natural log of 50 divided by the natural log of 3. Okay, however you want to do it, both of them are going to give you approximately 3.56. Okay, so if you were asked to change the base to evaluate that, you should get 3.56. Okay, all right, so you are now going to start working on your homework for section 5 of chapter 7. And again, if you have questions, please visit the math tutorial lab during lunchtime in F107. And happy expanding and condensing of logs. We will see you next time.